Here we are on page 10 of exponentials. Just a reminder here, when you have a base to an exponent, you can take the base and leave it in parentheses, factor it out. Once you factor it out, each element inside the parentheses needs to be taken to the exponent separately, okay? Because a lot of times people might say, oh, I'm going to factor out a 3, and they factor out the 3, and the 3, they don't think they need to take it to the exponent anymore, but since it is part of this base number, you can't just like pull it out like that, all right? Remember that the exponent has to come first. All right, so let's use the fact that we can break down the base into separate factors like that to simplify these expressions. All right, so if we have 12 to the n divided by 6 to the n, 12 to the n kind of looks like it's related to 6, right? What if we broke 12 to the n down into 2 times 6? Now we have 2 times 6 quantity to the n divided by 6 to the n. We can now take the exponent of n and put it onto each of the bases. So now we have 2 to the n, 6 to the n, divided by 6 to the n. And so now we can cross the 6 to the n's out, and we're left with just 2 to the n. Okay, let's go to E or C. 6 to the b divided by 2 to the b. 6 looks like it's related to 2 because 6 is 2 times 3, right? So we'll put 2 times 3 to the b divided by 2 to the b. Then we'll distribute the exponent to each of the elements underneath. We'll have, you can distribute exponents to factors. You can't distribute exponents to things that are added together, okay? We talked about that before. Okay, and then we just cancel those out, and we're left with 3 to the b. Okay, what I was saying was 2 times 3 to the b, there's a exponent rule that says that that's equal to 2 to the b times 3 to the b. But there is no exponent rule that says we can distribute the b here, right? This means you have to do FOIL. Okay? All right, moving on to E. 35 and 7 look related. 35 is actually 5 times 7, right? So we'll do 5 times 7 to the x divided by 7 to the x. So that's 5 to the x times 7 to the x divided by 7 to the x. 7 to the x's cancel out, and we're left with 5 to the x. Go to G. 5 to the n plus 1 divided by 5 to the n. No factoring of 5 needs to occur here, but we just remember that 5 to the n plus 1 is equal to the same base to each of the exponents. Oh, now we can cancel it out. So the answer is 5 to the first, which is 5. Okay, going back to A here. 6 to the m plus 2 to the m divided by 2 to the m. Okay, well, 6 is equal to 2 times 3, so we'll do 2 times 3 to the m plus 2 to the m divided by 2 to the m. And so we could factor out a 2 to the m from the top. We'll have 2 to the m, because this is equal to 2 to the m, 3 to the m, right? So we can factor out 2 to the m from the first term, and we'll get left with 3 to the m. We factor out 2 to the m from here, and we're left with 1. And then we have 2 to the m on the bottom, and we can cancel that out, and we're left with 3 to the m plus 1. Okay, go to C. Ooh, a to the n, that looks related to 2. 4 also looks like it's related to 2. We can write 2 times 4 to the n plus 2 times 2 to the n divided by 2 to the n. And then we could say, okay, let's distribute our n exponents. So we could have 2 to the n to 4 to the n plus 2 to the n, 2 to the n divided by 2 to the n. And now you can cancel these out if you know what you're doing. If you don't, then just factor it out. So 2 to the n factored out. I'm left with 4 to the n here and 2 to the n here. And then I'm divided by 2 to the n. I can cancel that out. And I'm left with 4 to the n plus 2 to the n. Okay? All right. E. 6 to the n plus 12 to the n divided by 1 plus 2 to the n. Okay, so 12 looks like it could be expressed as 2 to the n, 6 to the n, right? Then I can factor out 6 to the n. So then I'll have 6 to the n, factor out, and I'll have 1 plus 2 to the n left. And then below I have 1 plus 2 to the n. I can cancel these out. I'm left with 6 to the n. Okay, and then G. 5 to the n plus 1 is equal to 5 to the n times 5 to the 1, right? Same basis, different exponents. And I can factor out a 5 to the n now. I'll factor out 5 to the n. I'm left with 5 to the first minus 1. I'm dividing by 5 to the n. I can cancel those out. Then I'm left with 5 minus 1, which is 4. I. 2 to the n minus 1 is equal to 2 to the n times 2 to the negative 1. I can factor out a 2 to the n from both on top. So I'll have 2 to the n. I'll factor out 2 to the n from 2 to the n. I'm left with 1. I factor out 2 to the n from this, and I'm left with 2 to the negative 1. Then I divide by 2 to the n. I can cancel those out. I'm left with 1 plus 2 to the negative 1. 2 to the negative 1 is 1/2. So I'm left with 3/2. Last one, 6a. Says to simplify this. What if we expand it first? So I'm going to distribute the 2 to the n here. So I'll have 2 to the n times n plus 2 to the n plus 2 to the n plus 1 is just 2 to the n. Then 2 to the n times n minus 2 to the n times times 1. Then I can cancel 2 to the n minus 2 to the n. That gives me 0, right? Then I have 2 to the n times n plus itself. That would be 2 times 2 to the n, which is also equal to 2 to the first times 2 to the n. 2 to the first times 2 to the n is actually 2 to the n plus 1 multiplied times n. Okay? The other way you could do it is you could factor out the 2 to the n. If you factor out the 2 to the n, you're left with n plus 1 times plus n minus 1 on the inside. 1 and negative cancel out. The n's added together become 2n, and then you're ended up with 2n 2 to the n. 2 to the first times 2 to the n is equal to 2 to the n plus 1. You get the same thing. Okay?